Did you know that the closest star to us is actually more than 4 light-years away? So, just how massive is that distance when you crush the numbers into kilometers? And exactly how much time would it take to cross it in a regular everyday rocket? If we wanted to launch a traditional spacecraft toward Alpha Centauri, would it actually make it there within a human lifetime? Not a chance. It would literally take tens of thousands of years. So how on earth can we radically cut down this insane travel time? What if we actually used a super thin beam of light to push a tiny micro-sized spacecraft? Researchers from Texas A&M University have officially dropped a revolutionary idea that relies entirely on lasers. This entire idea actually relies on microscopic devices called MetaJets. So what on earth are these things anyway? And how can laser light completely control their movement without even touching them? If this technology actually works out, could traveling to another star completely become a reality in just 20 years? That is exactly what we are going to find out in the upcoming parts. So, to kick things off, light actually carries momentum, meaning that when photons smash into a surface and bounce right off it, they give it a tiny, super subtle push. This force is pretty much impossible to feel down here on Earth, all because of friction and gravity. But out in the vacuum of space, where there is absolutely no air or friction, the buildup of these constant light pushes is totally capable of gradually accelerating objects to insane speeds. For example, a laser could literally pump up the speed year after year. This whole concept is super similar to the idea of solar sails that catch sunlight, but lasers totally blow them out of the water with their insane ability to focus and control. That means a laser beam can be shot straight from Earth with absolute pinpoint precision right at a tiny target. The real revolution lies right in these MetaJets devices, which are microscopic structures with insanely complex geometric surfaces. This clever engineering allows researchers to completely control exactly how light reflects, and therefore seamlessly control the direction of the object's movement without even touching it. If a laser hits a regular surface, the push is just super simple and uniform. But by using MetaJets, the surface can be completely customized to bounce light in specific directions that generate complex thrusts, like pushing it sideways or even spinning it around. If scientists actually pull this off and develop this technology, they will build giant, massive lasers on Earth capable of blasting ultra-powerful energy beams. These lasers will push super lightweight spacecraft that do not weigh more than just a few grams. As a direct result of this, these spacecraft could actually reach about 1/5 the speed of light, meaning around 150,000 kilometers per second. And at that insane speed, the massive distance to Alpha Centauri, which is 40 trillion kilometers, gets completely crushed in just about 20 years. This incredible milestone will mark a massive, mind-blowing leap in the history of space exploration, where the very first human spacecraft will actually beam back close-up pictures and data from another star system right within a single human lifetime. Back in the day, we would have needed hundreds of generations just to make something like that happen. Alpha Centauri is actually super fascinating, mostly because it is not just one single star, but a wild trio of 3 stars all orbiting each other. The whole setup is called Rigel Kentaurus, and it is made up of 2 massive stars pretty much just like our Sun, plus a tiny red dwarf star. On top of that, this entire system actually hosts planets, like for instance, the red dwarf star Proxima Centauri totally packs a planet called Proxima b. This planet is sitting right in the habitable zone, which means liquid water could actually exist right on its surface. But as of right now, all of these experiments are totally still locked inside labs on incredibly microscopic devices. Scientists have not actually proven yet that the system can fully function in the real vacuum of space, or that a laser can seamlessly track it with absolute precision across millions of kilometers. On top of that, there is a massive, absolutely insane engineering challenge when it comes to generating enough laser power to actually push a larger spacecraft that carries cameras and sensors. For instance, the required capabilities totally blow away the most powerful lasers we have right now by millions of times. We also absolutely have to solve the problem of aiming the laser with absolute pinpoint precision across vast distances, because any tiny little mistake at the very beginning will cause the spacecraft to veer off its path by millions of kilometers. If it drifts by even just 1 single degree, it will literally be lost in space forever. So, the whole idea of MetaJets and lasers is incredibly promising on paper, but it totally needs decades of deep research and development to actually become a reality. And only then, the very first human encounter with another star system will finally be completely possible right within our lifetime.